So the other type of vector multiplication that we need to take a look at is the cross product. And we mentioned it briefly at the beginning of the lesson where we talked about the dot product, but here we're going to go into detail just on how you use or how you determine the cross product of two vectors. So just like we did with the dot product, we want to be able to find the cross product or the vector product of two vectors if those vectors are given to us in geometric form with magnitudes and angles, or in algebraic form as ordered pairs or ordered triples. And then we'll do some practice questions where we use the properties of the cross product to solve problems involving vectors. So just like we saw with the dot product, here is sort of the summary of the cross product. And as we go through this, we're going to highlight some of the things that are similar to what we saw with the dot product and point out sort of the important differences. So the first thing to remember is that the cross product, also known as the vector product, produces a vector as its result. So we're going to have to talk about both the magnitude of that resultant vector, and then after we've done that, we'll talk about what the direction of that resultant vector is. So again, we have our same two vectors that we had in the last lesson, vector A with a magnitude of 5 at a direction of 53.1 degrees, and vector B with a magnitude of 7 at a direction of 0 degrees. And as before, we can also think of these as algebraic vectors. A was 3, 4, and B was the vector 7, 0. So to start with, we imagine A and B placed tail to tail on our Cartesian plane here. And the formula up in the red box here tells us the magnitude of the cross product, A cross B. So it says that the magnitude of A cross B, of that vector that's the result of doing the cross product, is the magnitude of A times the magnitude of B times sine theta. So we can think about that the same way we thought about it in the previous lesson. If I rearrange this formula a little bit, so it's magnitude A sine theta times the magnitude of B. We know from our discussion of components that magnitude of A sine theta is going to be this vertical component here of our vector A. So A sine theta. And again, our angle between them is still our 53.1 degrees. So to get the magnitude of our cross product, we take the part of A that is perpendicular to B, so this magnitude A sine theta, and then we multiply it by the magnitude of the B, and that gives a vector B, and that gives us the magnitude of our resultant. So with this set of vectors here, we can say that the magnitude of A cross B is magnitude A, magnitude B, sine theta. We know our magnitude of vector A is 5. Our magnitude of vector B is 7. We do the sine of the angle between them, which is that 53.1 degrees. And we punch this into our calculator, and we get an answer of 28. So 28 is the magnitude of the cross product of vectors A and B. Now, what about the direction? When you do the cross product, the resulting vector is always perpendicular to the two vectors that you started with. So perpendicular to both A and B. Now, you might be thinking, how is that possible? How can I draw a vector on there that is perpendicular to both A and B? Well, we've drawn these vectors in 2 dimensions. The cross product is a 3-dimensional operation. So the vector that represents our cross product isn't going to be in the plane of the board here, in the plane of the page. It's going to be coming out or going in. How do you know that direction? If you've studied physics, you've encountered a thing called the right-hand rule. The right-hand rule is what lets you figure out the direction of the vector. So I've got 2 different vectors here, vector A and vector B. A has a magnitude of 10, B has a magnitude of 5. I put an angle of 110 degrees between them. Let's say we want to evaluate A cross B. Okay. What you would do is you would take your right hand. Now this is a little tricky if you're watching this video. but just kind of imagine taking your right hand, stretching out your four fingers, having your thumb pointed so it's perpendicular to your four fingers, so basically holding your hand really flat, okay? Take your four fingers, start at the tail of vector A, because it's our first one, vector A, and point your fingers towards the tip of vector A. So just along like that. Okay? So your fingers would, the heel of your hand would be down here, and your fingers would kind of be pointing in that direction. Now what you want to do is you want to curl your fingers so they point towards vector B. So I'm curling them, they kind of go up and around like that, okay? So I curl my fingers sort of along this line like this. My thumb is now pointing in the direction that the cross product will go. So my thumb is pointing directly out of the board or out of the page here. So my direction for A cross B is perpendicular out of the board. Now, imagine, so that was in red here. Imagine if instead of doing A cross B, we wanted to do B cross A in the other order. Well, I would take my hand, again, pointing out my four fingers, and I would place it along, so my fingers are pointing in the direction of vector B. Okay, so my fingers are pointing out like this. If I try to curl my fingers in the direction of vector A, if I curl them like this, down like that, I'm kind of going the wrong way around. So what I have to do is I have to flip my hand over so that my fingers can curl this direction towards vector A. Now my thumb is pointing directly into the board. So the direction of B cross A, instead of coming out of the board, is going perpendicular into the board. And that's the right-hand rule. So returning to these two vectors that we started with, if I have A cross B, I'm going to point my fingers in the direction of vector A, curl them down towards vector B. My thumb is pointing into the board. So it's perpendicular to A and B with the direction given by the right-hand rule. So in this case, this is going into the board. So our vector, A cross B, has a magnitude of 28 and a direction going into the board. So that's if you're given two geometric vectors. What if they give you algebraic vectors? Just like we had before. Two new vectors, A and B. These are three-dimensional vectors. There is a formula that you can use to evaluate A cross B. Okay? It's kind of tricky to memorize that formula. So the way I remember how to do it isn't a formula, it's kind of an algorithm. And it's sort of a visual algorithm. So I'll show you how it works here. And then you'll have to practice it a little bit to get used to it. If I have vectors A and B, what I'm going to do is go over to the side of the page here, and I'm going to make myself a little chart. To start with, it's going to have three columns in it. One for my X component, my Y component, and my K and my Z component. So I've labeled them I, J, and K hat for those three directions. Under those headings, I'm going to write my two vectors. I'm doing A cross B, so I want to write vector A first. So 7, 5, -2. And then underneath that, I'm going to write vector B, -3, 8, 1. Then I'm going to add another copy of my I column and my J column. So my I's are 7, 5 again, and for, oh no, sorry, 7, and then my j is 5. And then for my second vector b, my I is -3, and my j is 8. So I've set up this little table. And this table is what I'm going to use to remember the operations that I need to go through to figure out the cross product. So my cross product is a vector. It's going to be a three-dimensional vector, so it's going to have 3 components. So we first have to do the I component, then the j component, and then the k component. So if we want to do the I component, what we do is we remember a pattern in this table. So we start at the I and we go down on an angle like this. So down and to the right. Okay? And we're going to keep going down like this, and then we're going to loop around the bottom, and then we're going to go back up on another angle. Okay? As we go down and as we go up on that angle, we are multiplying the 2 numbers. And then as we turn around on the bottom, we're subtracting the result of that. Okay? So starting at the I, we go down on an angle to the 5 and then the 1. So we're going to get 5 times 1, and then we subtract, going up on that angle, 8 times -2. The result of doing that calculation is the x component of our cross product. And then we have to do the same thing for our y and our z. So if we want our y component, go down on an angle, so we're going down, looping around, and then coming back up again. So our y component is going to be -2 times -3 minus 1 times 7. Same operation for our k component. Down on an angle. We're going to multiply the 7 and the 8, and then subtract the -3 times the 5. 7 times 8 minus -3 times 5. So if I do those 3 calculations, that's going to give me my vector. So 5 times 1 is 5. 8 times 2, 8 times -2 is -16. So 5 plus 16 is going to give me 21. -2 times -3 is 6. 6 minus 7 is going to give me -1. And then 7 times 8 is, what, 56? And then I am adding 15. That's going to give me 71. So this whole calculation here gave me this 21. This calculation here gave me the -1. And this calculation here gave me the 71. And that's how you carry out a cross product. So let's make sure that this, this formula actually makes sense. We'll return to the 2 vectors that we had on the previous slide. We have our vector A, 3, 4, and our vector B, 7, 0. Let's use this method to evaluate the cross product of those 2 vectors. First, you have to think of these 2 vectors as being 3-dimensional vectors. Right now they're 2-dimensional, so we have to add in the z component. So we'll think of A as 3, 4, 0, and we'll think of B as 7, 0, 0. We'll come over to the side here, set up our little chart. 3, 4, 0, 7, 0, 0. Another copy of 3, 4, another copy of 7, 0. We want to do A cross B. So, again, my x component is going to be 4 times 0 minus 0 times 0. which just gives us 0. That was our x component. The same color here. Our y component is going to be, go down on the angle, 0 times 7 is 0. So 0 minus 0 times 3 is 0. 0 minus 0 is 0 again. Our k component, going down on the angle, 3 times 0 is 0. We're going to subtract 4 times 7. 4 times 7 is 28. So 0 minus 28 is going to be negative 28. So when we do the cross product of those two vectors, a and b, we get 0, 0, negative 28. So a vector with a magnitude of 28, which is traveling in the negative z direction. So if we return to our picture here, our x-axis is over here, our y-axis is up here, our z-axis is going to be coming out of the board vertically. So our negative 20, our vector 0, 0, negative 28 has a magnitude of 28 and is traveling into the board. Okay, the same answer that we got when we did this geometrically. All right, and that's the cross product.